In this video, I'll be discussing the 5 gas laws that we obtained from the ideal gas law. So I talked about the ideal gas law in the previous video. If you don't know it, I would recommend watching that video first, because we obtained the other 5 laws from this law. So it was, if you remember, PV equals nRT. Now, as I said, there are 5 more gas laws that you can simply obtain by knowing this equation. The first law is what we call Boyle's law. And well, we get these different laws because they wanted to separate this equation, the ideal gas law, into many variables. Instead of having 4 variables, having 2, let's say. So you don't need to be given all of these different values to obtain, let's say, the volume or something. You could just obtain it from just having the pressure, like Boyle's law says. So Boyle's law says that the number of moles and the temperature will be constant. So I'm going to write this constant will be the N and the temperature. So that will only leave us with the pressure and the volume. Well, because the R is a constant, so we don't really count it. So the only variables we will have, this is stating Boyle's law, would be the pressure and the volume, right? Now let me erase this. So if they're telling us that we have the number of moles and the temperature constant, we could just say that this and this is gone. So that would simply leave us with the pressure and the volume, and well, the R is a constant, so you don't really consider it. So we'll obtain the relationship that 1 over V is equal to the pressure. Or, in other words, the pressure is inversely proportional to the volume. So there comes an equation that Boyle stated. So he said that as the volume decreases, the pressure will increase. Well, because they're inversely proportional. So the equation will be P1 times V1 is equal to P2 times V2. That is Boyle's equation. So, I mean, as you can see, just so to obtain the pressure of something else, you don't need the number of moles or the temperature. You only need the volume and the pressure of the other factor we have. I'll be doing problems in another video because there are 5 laws, and it's easier just to say them and then solve problems in a different video, just to not make it too long. So now let's talk about the second law. That is Charle's law. Wrong color. So Charle's law. Now, Charles said that in this case, what we have constant will be still the same number of moles, but this time the pressure. So we'll be wanting to make a relation between the temperature and the volume instead of the volume and the pressure. So back to our ideal gas law, PV equals nRT. Well, they told us that this part and this part is constant, and the R is always constant. So it will leave us with V equals T. So the volume is proportional to the T. So, in other words, as the volume increases, so will the temperature. So then we will get this formula. V1 over T1 is equal to V2 over T2. So this is the Charles equation, Charles law equation. So what this does is that if they give you, let's say that you have water and, no, it's actually gases. So let's say you have chlorine and water vapor. So if they give you the volume of chlorine you have and the temperature of it, and they give you the temperature of the water, so you will have V1 for chlorine, temperature 1 for chlorine 2, and the temperature for water, you can obtain the volume of that water vapor. So that is how you use Charle's law. But again, I'll be solving problems in the next video. Now the third law is the Guy-Lussac's law. And he said that what we have constant are still the number of moles and the other variable is the volume. So that would leave a relationship between the pressure and the temperature. So let's see how that works. We have PV equals nRT. So this is gone, this is gone. Then we only have the P is equal to T. So in other words, the pressure is proportional to the temperature. So as the pressure increases, so will the temperature. As the pressure decreases, so will the temperature. So our equation would be P1 over T1 is equal to P2 over T2. So you can see again, you don't need all the variables to obtain the pressure of a gas or the temperature of a gas. Now the fourth law is pretty much a combination of the previous laws. So, well, its name will tell you. It's called the combined gas law. Combined gas law. It's our fourth gas law. And well, it'll be only saying that what we have constant is the number of moles again. So in other words, we'll have an equation with pressure, volume, and temperature, and the R is always constant. Let me fix that N. Yeah. Okay. So PV equals nRT. This will be gone. So to put it as an equation, it would be that PV over T is equal to PV over T, but this will be P1, 1, 1, and then 2, 2, and 2. So it's these minor equations are always for two gases, two samples of gases. So you'll always have like a pressure 1 and a pressure 2, instead of like the ideal gas law in which you only have the pressure of one sample of gas. So this is our combined gas law. And pretty much you will use this whenever you have everything except the number of moles and you cannot obtain it. So you use this equation instead of the ideal gas law. So now let's go to the last one. And it's something that we really talked about before. It's called the Avogadro's law. Well, you can remember Avogadro from its number 6.022 times 10 to 23 molecules. But that doesn't really matter now. However, it gives you a hint onto which will not be constant this time. So Avogadro said that what will be constant will be the pressure and the temperature. Then so what that would leave us would be the volume and the number of moles. So a good way to remember Avogadro's law is that it's the only one that says that the moles are variable. The Guy-Lussac Charles and Boyle's law, as well as the combined gas law, in all of them, the number of moles were always in the constant box. However, in Avogadro's law, it will be a variable. So it's an easy way to remember Avogadro's law. So now let's actually use the ideal gas law to say how the relationship would be. So we have this and this constant. So the volume is equal to the number of moles. So this means that they are proportional. And as the volume increases, so will the number of moles, and vice versa. So our formula would simply be V1 over N1 is equal to V2 over N2. V2 over N2. And those are the 5 laws involving gases or gas pressure. And I'll put the link in at the end of the video, so it's somewhere right here, to if you want to see problems in which I use all 5 laws.